Welcome to the deep dive. Today, we're getting into a really critical topic for anyone building tech right now. We're talking about protecting your valuable intellectual property, specifically those unique algorithms in this age of AI.
Yeah, it's become incredibly important. We're seeing this huge acceleration in software development. Things like no-code tools, all the open source models available, AI helping with coding. It's really opening doors.
It really is.
Yeah.
And it's empowering a whole new group of people to build things, especially APIs, right?
Absolutely. Consultants, educators,
Yeah.
people in health, logistics, folks with deep expertise in their field are now building software.
We actually had a client recently really excited about a new API they built for a very specific audience. Great idea.
Yeah.
But then came that question, the one I bet a lot of you listening have.
Yeah.
How do I stop someone just taking my algorithm, copying the core
So
logic?
that's the heart of it. AI lets more people build, which is fantastic for innovation. But, it also creates new risks. Your IP might be more exposed if you're not careful.
So that's our mission for this deep dive, figuring out how to navigate that risk.
Right. How do you protect what makes your creation special?
Okay, so let's talk about this new software builder phenomena. These aren't always traditional coders.
That's the key shift. They're experts in their domain, maybe not necessarily in IP law or secure coding or even algorithm design theory.
And what's the risk there? What could happen if they don't think about protection?
Well, the danger is that an algorithm they've spent maybe years perfecting based on their unique knowledge could potentially be copied quite easily or reverse engineered. Someone could figure out how it works and replicate it.
Or just use it without permission, integrate it into something else?
Precisely, which undermines their competitive edge, their business value.
Okay, so let's define terms. What exactly makes an algorithm proprietary in this context?
Fundamentally, it's the unique logic, the specific steps and structure you've created that gives your software its power. It's what provides that competitive advantage or delivers the core value, your secret sauce, so to speak.
The secret sauce, I like that. But you mentioned just calling it proprietary doesn't legally protect it.
Not at all. That term has no inherent legal weight on its own. You need to take concrete steps.
Okay, so what are those steps? How do you make it legally defensible?
First, it needs to be original. Genuinely your creation, or if based on open source, significantly modified and built upon by you.
So no simple copy pasting.
Definitely not. Second, documentation is crucial. You need thorough records showing you created it, when, how, its evidence of authorship.
Well, I've been keeping a detailed lab notebook, but for code.
Exactly. And third, you either have to keep it secret, actively maintain its confidentiality, or if you share access, like through an API, you need very clear licensing terms spelling out the rules.
Okay, originality, documentation, and secrecy, or clear licensing. That makes sense. Now, you also mentioned where you put the algorithm in your system. Architecture matters a lot.
Oh, absolutely critical. You really want to avoid exposing the full logic in your front-end client.
So not in the web page code or the mobile app itself.
Right. Because those parts are inherently easier for someone to inspect, to poke around in, and potentially figure out how things work. Reverse engineering is much easier there.
So where should it live then? What's the best practice?
Ideally, your core proprietary logic should reside on a secure backend. Think secure cloud servers. Access should only happen through authenticated API calls. You expose the inputs and outputs, not the internal workings.
I see. So the user sends data, the magic happens on your secure server, and they get the result back.
Precisely. Using platforms like AWS Lambda, Google Cloud Functions, or containerized setups like Docker helps manage this, and you need things like encrypted traffic, robust authentication, maybe rate limiting on those API calls.
Okay, so that protects the algorithm itself, but it sounds like it also just makes for a better, more professional system overall.
It really does. It's better for security, yes, but also for scalability. You can manage and update that core logic centrally. And it presents a much cleaner, more professional interface to anyone using your API.
Makes sense. So beyond just where it lives, what about technical tricks? Things you can build in to deter copying?
Yeah, there are several technical safeguards. Strong authentication is a baseline. Make sure only authorized users or systems can call your API.
Right. Stop unauthorized access.
And rate limiting, that helps prevent people from just hammering your API to scrape data or try and deduce the logic through sheer volume of requests.
Prevents abuse, essentially.
Exactly. Then you have techniques like code obfuscation.
What's that involved?
It basically scrambles your code, makes it much harder for a human to read and understand if they somehow got access to it. It's not perfect, but it raises the bar.
Another barrier.
Yes. And code splitting, breaking the logic into smaller, potentially less revealing pieces, harder to see the whole picture. Also really important, logging and monitoring. Keep track of who's using your API, how much, look for suspicious patterns.
So you can spot potential misuse early.
Right. And finally, encrypting any sensitive data that goes back and forth protects the payload itself during transmission.
Okay, so authentication, rate limiting, obfuscation, splitting, logging, encryption. It's quite a list.
It is. And none of these are individually foolproof, you know. A determined attacker might get past one, but together they create layers. It makes it significantly harder, more time-consuming, and riskier for someone to copy or steal your logic.
It's about making it not worth the effort, essentially.
That's a big part of it, yes. Increase the cost and complexity of attacking.
All right, let's shift gears a bit to the legal side. We've touched on it. But what are the main legal tools creators can use?
Okay, so legally, non-disclosure agreements, NDAs, are fundamental. If you're working with freelancers, contractors, advisors, potential partners, anyone who might see your confidential information, get an NDA signed.
That seems like standard practice, but crucial.
Absolutely crucial. It creates a legal obligation for them to keep your secrets.
What about broader protections?
While there's copyright, you can register your actual source code as a literary work. But, and this is a big but, copyright protects the expression, the literal lines of code you wrote. It doesn't typically protect the underlying idea or the algorithm's logic itself.
So it stops direct code copying, but maybe not someone re-implementing the same idea in different code.
Generally, yes, that's a key distinction. For the core logic, if it's truly novel and kept secret, you might look at trade secret protection.
Trade secrets, how does that work?
It protects confidential business information that provides a competitive edge. Your algorithm could qualify. But the key is you must take active, reasonable steps to keep it secret. Limit access, use confidentiality markings, have internal policies.
So it requires ongoing effort to maintain that status.
Very much so. If you disclose it without protection, you can lose trade secret status.
What else? We mentioned licensing earlier.
Yes, licensing agreements are vital if you are letting others use your API. These contracts need to be really clear about what they can and can't do, who owns the IP, and explicitly forbid reverse engineering.
Got it. Spell out the rules clearly. Any other major legal avenue?
For some algorithms, particularly very novel ones in specific fields like, say, fintech or biotech, maybe even some data science areas, a patent could be an option.
Patents for software algorithms.
It can be complex, and not all algorithms are patentable subject matter. But for genuinely inventive processes, a provisional patent might be worth exploring. It offers potentially the strongest protection for the inventive concept itself, but it's a more involved and often costly process.
Okay, so it really sounds like a mix is needed. Technical safeguards and legal protections working together.
Absolutely. Relying on just one isn't enough in today's world. You need that layered approach, technical walls reinforced by legal agreements and potentially classifications like trade secrets or patents.
So pulling this all together, AI is driving incredible innovation, making powerful tools easier to build.
Right. Lowering the barrier to entry.
But that innovation is vulnerable if it's not protected, especially the core algorithms.
That's the crucial point. Founders, freelancers, consultants, anyone building these tools now needs to think about IP protection right from the start. It's not just for the big tech companies anymore. It's part of the development lifecycle for everyone.
So the message is, put as much thought into protecting your creation as you do into building it.
Precisely. Build ambitiously, absolutely. But build smart. Build with protection in mind. That's key for long-term success and keeping the value you've created.
This has been incredibly helpful. A really important deep dive for anyone building with unique logic today. Thanks for breaking it all down.
My pleasure. It's a landscape that's constantly shifting, so staying informed is vital.
And for all of you listening, if you want to explore this topic further, you can read more from Frederick Griffin. Just head over to www.gaghmanagementpartners.com and look for the Think Pieces section.
Yeah, some good resources there for digging deeper into these strategic considerations.
So as you go out and build the next amazing thing in this AI-powered world, here's something to think about.
How will taking proactive steps now to protect your unique creations actually define the future impact and trajectory of your innovation? Worth considering. Thanks for joining us on the Deep Dive.